Uh, Namaste, all of you, uh, all my dear friends, and our respected course facilitator, dear Simkada sir. Today, I am going to present about on the topic of promoting students' engagement and motivation in mathematics teaching learning. Moving ahead, the outlines, learning outcomes, factors influencing students' motivation in mathematics, engagement and motivation strategies in mathematics, active learning techniques enhance uh, active learning through constructions and derivation of formula, slant height, age, total surface area, lateral surface area, and learning outcomes are at the end of this training session. Teacher training will be able to construct a square-based pyramid by using hands-on activities and demonstrate the pyramid using its net, derivation the formula of slant height, length of edge and vertical height, and TSE and LSE. Okay, let's do before beginning the session. Let's do small warm up activities. Okay, could you guess the possible values? Okay, these are these are the answers. So, in students' engagement and motivation, there are different factors. Factors are there, and here today we'll discuss and discuss about some major influencing factors. These are teachers influence, peer influence, curriculum and instructional methods, personal factors, teacher students interaction, social and off-task behavior, academic time spent on homework. And next slide is about engagement and motivation strategies in mathematics. So, how can we engage and motivate the students towards the mathematics learnings? So, there are uh, some measured strategies. Uh, they are active learning techniques, technology integration, collaborative learning, differentiated instructions, and real and relevant tasks, open-ended tasks, and using factors as a focus for learning in mathematics lessons. Active learning techniques to enhance students' motivation and engagement in mathematics educations. Educators can apply the different strategies that make subject more interactive, relevant, and accessible. And active learning techniques moves beyond the theory to active application, fosters more profound understanding of the subject matter, and increase motivation by solving meaningfully practical problems. They see the relevance of mathematics, which engage and motivation. Teachers influence in learning techniques to enhance students' motivation and engagement in mathematics. Teacher's role is crucial, and a teacher can apply various approaches. There are among the various approaches. Uh, the first one is active learning through hands-on activities. Let's get ready for enhanced active learning through formula derivation of square-based pyramid through hands-on activities. For enhancing active learning, we can involve students by uh, engaging in hands-on activities. The tasks are each trainee will be divided into each group including 4 or 5 members, and they will be provide the sheet of cardstock, A4 size graph paper, ruler, and scissors, and construct a square-based pyramid shown in 3D model of square-based pyramid. And objectives are defined in terms base is vertical height, slant edge, TSA, and LSA. Construction procedure. For instance, let's take an A4 size graph paper and mark base 4 units of base and 5 units height at edge. Join the vertex from each of base, and after joining, cut by using scissors, and the net of square base pyramid is ready, which is uh, shown in the uh, figure also. And using glue, fold edges and concrete square base pyramid is ready. And for height of the pyramid, make a dot of in the center of the square base and stick perpendicularly by using glue up to the apex. And concrete exploration. Instead of writing formula on the board, teachers will explore through mentally and physically. The first step is derivation of formula for slant height, and the activities are uh, first activities is by using a transparent pyramid model, right angle triangle inside square base pyramid, and the logic is they will show the vertical height is h, slant height will be denoted by L, and half of the base is will be divided by A by 2 from the right angle triangle using uh, using the uh, using the uh, Pythagoras theorem, and teachers will discover it. L square is equal to S square plus A by 2 whole square, uh, and deriving formula of slant is that's the activities point to the corner vertex of the base, and they will show the triangle formed by slant height, half of the base, and slant edge. Logic is this is another right angle triangle on the face of the pyramid. Here also similarly they will apply the Pythagoras theorem. H square is equal to p square plus b square, where uh, E denotes edge and L denotes perpendicular height and A by 2 denotes base. Deriving formula of TSC and LSC. The first activity, a point to the corner vertex of the base, show the triangle formed by the slant height, half the base edge, and the slant edge. Second activity is show the area of base, uh, that is L times P, where uh, the base is square, so area base will be L square, or it will be denoted by A square. And so the area of triangular faces LSC, uh, LSC uh, triangular faces by LSC is 2AL, and logic is total surface area means sum of base area and LSC. Then the formula will be TS is equal to A square plus 2AL. For deriving formula of volume, the first activity teachers will be engaged in the by a short video. Okay. Uh, then again, uh, next video also will be helpful.
I'm going to show that the volume of a square pyramid, it's a pyramid with a square in the base, is the same as 1/3 of the volume of a rectangular prism with the same base and the same height. So this thing has the same base as the pyramid, same shape, and has the same height as the pyramid. And so this should be 3 times as big as this. And the way I'm going to do that is by transforming a pyramid into this shape. And this shape looks very different, but it's really just this pyramid where each of the layers has been shifted over. Let me show you what I mean. Okay, so here's a pyramid with the same volume as this. So these two the same height. And this one I said is just a shift, so let me shift things over. And we'll shift these things over. And so this shape here now is exactly the same as this shape here. So I try to show that this volume is the same as that volume, and so it's is the same as this volume of this piece. So if I take 3 of these pieces, here are three of these, all have the same volume as this, and put them together, they form a cube. So this cube is 3 times the volume of this, or in other words, this pyramid is 1/3 the volume of the prism with the same base and the same height. I'm going to show that the
Okay, after just watching this video, teachers teachers will be clear about the rectangular prisma box or prisma. Rectangular prisma is uh, the triangular part is 1/3 of the rectangular prisma. So volume will be 1/3 of area base into height. And next session is about teachers training will involve in reflection and wrap up for 5 minutes, and they remind them that formalized square base pyramid is just Pythagorean theorem indeed, uh, and the reflection from the session will be they will reflect. And next is about references. And by saying this, thank you all of you.